channel Medical Stores. So today we are going to be doing topics acid and base, some of their properties and the relationship between pK and Ka. So let's get started. So here we start our first topic. So we will basically differentiate between acid and base. So during my last video we have discussed between acidic amino acid and basic amino acids. So it is the same. Acid are the proton donors. Proton means hydrogen ions. Base are proton acceptor. So basically we have weak acid and strong acid. So what are strong acid? Strong acid are those which completely dissociate. Which completely dissociate and the second one is weak acid. Weak acid are those which partially dissociate. In any acidic solution. Same for this too. In any acidic solution. For base, we are having only strong base. So strong base are those which partially dissociate. We do not have weak base. Okay. So here you can see one equation. Here water is acting as both acid and base. So the portion which is highlighted with black. Here water is an acid form. It donates its proton where it generates H3O plus and it is free as OH minus. So it works as acid and the product which is generated is known as its conjugated base. The same will be for this one. Here which is highlighted with orange, the water is acting as a base. Basically it accepts proton. We have seen that acid are the proton donors, base are the proton acceptors. So in this equation which is highlighted with orange, water is accepting a proton from this one. So this one is the base and the product which is generated is known as its conjugated acid. Okay, so from this we can get that water acts as both acid and base, so therefore the pH of water is always neutral. So we can tell that water is a proton donor which is acid, work as acid, and it gives this product which is known as conjugated base. Second thing we can tell is water is proton acceptor where it works as base, this one, and its product is conjugated acid. Okay, So basically I have to just explain you this, that acid will always give its conjugated base, and a base will always give its conjugated acid as a byproduct. Okay, in this reaction, so basically if you have to define what is conjugated base and conjugated acid. So what is conjugated acid? It is basically is a base with hydrogen added to it, hydrogen ion added to it. So here we can see this one is the conjugated. So here we can see this one is the conjugated acid where a hydrogen ion has been added. So this one is the conjugated acid. So you can write it. It is a base with added hydrogen ions to it. And if you have to define conjugated base, so conjugated base is the leftover after an acid has donated its proton. So here we can see this one is the conjugated base, this one is the acid. Acid has donated its proton, and what we get the leftover, that is known as conjugated base. So here we can write the leftover after an acid has donated its proton. Okay, so I think this both the concept is clear. So this is our second topic, acid dissociation constant. Before moving on to the pH and pK topic, I wanted you to know this one. So what is acid dissociation constant? It is nothing but basically we define it as K. This is the sign, this is the acid dissociation constant. K is nothing but it measures the strength of acid in a solution. Okay, so it measures the strength of the acid. Let me write, sorry. It measures the strength of acid. So here is one equation. Here HA is nothing but it is a weak acid. We can, this A is changeable, it can be any acid. This is a weak acid. After the reaction we get it as a conjugated base. So this reaction, through this reaction we can find out Ka, which is dissociation constant. It is equal to product upon concentration of the product upon concentration of weak acid and the concentration of water. So next step will be, we take here water is as constant, so basically this will be cut, and what we will get is concentration of the conjugated base upon the weak acid. So basically we can write this equation as minus log of K is equal to Pk, and hence we can get Pk is equal to K. Okay, this we saw in our last equation was Pk is equal to Pk is equal to K. So what is basically Pk? So Pk is used to express the relative strength of both acid and base. So can write Pk used to express the relative strength of both acid and base. Next we will see the relationship between pK and pH. So basically pK is equal to pH. So if we have to define the relationship between pK and pH, so pKa is the pH at which at which the concentration of acid equals to the concentration of base. Okay, pK is pH at which the concentration of acid is equal to the concentration of base. You can tell that pK is similar to pH. So it tells us how strong or weak an acid is. How strong or weak an acid is. Okay. So the relationship between pK and Ka, we will be comparing them with the acidic strength. So through given value of pK and Ka, you can conclude that which one is the strong acid or which one is the weak acid. So first we will see the relation of pK and its acidic strength. Okay, so for pK and acidic strength, they both are inversely proportional to each other. That means if pK value is higher, so the acidic strength, I will write it as AS, the acidic strength will be low. That means if the pK value is high, so the acidic strength will be low. That means it will be a weak acid. And if pK value is low, that means acidic strength will be high and it will be strong acid. Okay, so the relationship between pK and acidic strength is inversely proportional. Vice versa for Ka. We'll see for Ka and acidic strength. So here they are directly proportional to each other. That means if Ka is high, its acidic strength will be high and it will be a strong acid. Okay, and if Ka will be low, its acidic strength will be low and it will be a weak acid. So this is the thing which you should remember. It is not to memorize, you can just understand it. pK and acidic strength relation, that they are inversely proportional to each other, and Ka and acidic strength relation, they are directly proportional to each other. Okay, so this one is important, so you should remember this. Okay, I will see some example related to this concept. So for example, there are two acids. Okay, one is acetic acid and another one is formic acid. So if they have given you the pK value for acetic acid is 4.76 and pKa for formic acid is 3.75, and you have to see that which one is the strong acid. So here we have seen that relation for acidic strength and pK is inversely proportional. So if pK value is high, its acidic strength is low. That means the acid given is a weak acid, and if pK is low, its acidic strength is high. That means the acid given is strong acid. So from this, pK for this formic acid is low. That means its acidic strength is high, and this one is the stronger acid compared to the acidic one, because its pK value is high. So this one will be a weaker acid. Okay, so now what if they have given you the value of Ka? So we will look at that example. So if this is hydrofluoric acid, this is hydrosulfuric acid. So if the value of Ka for this is 6.3 into 10 to the power minus 4, and the value for this is 1 into 10 to the power minus 7. So we have seen Ka relation with acidic strength. They are directly proportional to each other. So if Ka value is high, its acidic strength is high, that means it is a strong acid. If Ka value is low, its acidic strength is low, that means it is a weak acid. So in this, from both of this, which one is the stronger acid? Which one is the higher value, -4 or -7? The higher value is -4. That means this Ka value is higher, its acidic strength is high, that means this one is the stronger acid, this one is the weaker acid. Okay, so you have to just understand this concept. You can solve any question related to Pk or K. Okay, you can also remember this concept. The Ka for strong acid is always positive, Pk for strong acid is always negative. So if in question, if they have asked you, they have given you the Pk value in negative, so what will its K, so the value will be the same, but only signs will change. Same for weak acid. K for weak acid is negative, it's vice versa. Pk for weak acid is positive. Okay, so this is also one thing which you should remember. Is for weak acid. For weak acid, the Pk value is always between -2 to 12, and for strong acid, Pk value is less than -2. Okay. This is also one thing which you should remember. It basically covers two topics. The one is the relationship between acid and base, their properties. So we studied what is conjugated base, what is conjugated acid, how should we define it. After that we studied what is acid dissociation constant K. We got this relation, Pk is equal to K. After this we studied what is Pka, what is its relation with the pH. In the next video we will look at in this deeply related to Henderson's Hasselbalch equation. After this we studied the relationship between Pk and K. I told you that this concept is important. If you understand this, you can solve any problem. So these two are important. I gave some examples. We studied this. I told you that this is also one thing which you should remember. And then for weak acid, Pk is always between -2 to 12, and for strong acid, Pk value is always less than -2. So here I finished my video. So for this topic I will refer you HARPERS book. They have given a good concept, good explanation in this book. I saw it in Lippincott. This topic is not included, so I will refer you HARPERS for this topic. So thank you for watching my video. See you in my next video. Thank you.